Hello and welcome back to Cloud Native Development on Azure with Java. Let's dive right in and set up our development environment to work with Azure Cloud Services. This video will guide you through the steps of deploying the necessary prerequisites and setting up your development environment using Azure Virtual Machine, or VM for short. First, let's understand some basic Azure terminology. Two important terms that you should be familiar with are Azure Resources and Azure Resource Manager. The infrastructure for your Azure cloud application is typically made up of many components, which could include a virtual machine, a storage account, a virtual network, or a web app, database server, and third-party services. All these components are called resources within the context of Azure Cloud Services. Furthermore, within the scope of a single cloud application, typically, these resources behave as related and interdependent parts of a single entity, which means they are generally deployed, managed, and monitored as a group. Azure Resource Manager enables you to work with the resources in your solution as a group. Let's dive right in and set up our development environment to work with Azure Cloud Services. This video will guide you through the steps of deploying the necessary prerequisites and setting up your development environment using Azure Virtual Machine, or VM for short. Let's start by exploring the Azure portal. Here you can see I have navigated to the Azure portal. You can follow along by navigating to https://portal.azure.com. In order to use Azure services, you need to, sign up for Azure. Microsoft does offer trial accounts for you to play around with the Azure services. So let's go ahead and create our first virtual machine. Most of the actions you need to take in the Azure portal start here in the navigation panel on the left-hand side. A virtual machine is also a resource, and when we want to create a new resource, we typically start by clicking this button at the top called, Create a Resource. This will open up the Azure Marketplace. Azure Marketplace is an online applications and services catalog of sorts. Customers, who are mostly IT pros and developers, they can discover, try, and buy cloud software solutions built on Azure or built for Azure. Here, our intention is to create a virtual machine, which is a compute type of Azure resource. So let's go ahead and click the compute link to view the compute offerings available for Azure. So as you can see, Azure offers a whole range of operating systems, including different flavors of Linux. For now, let's go with Windows Server 2016. So click on that. Click on Windows Server 2016 Data Center Edition. This will start the Create Virtual Machine wizard, which will guide you through the series of steps to deploy this VM. Let's fill out the details of this VM. First, you need to pick a name for the VM. This name needs to follow certain naming conventions, like it needs to be unique within the resource group, and it can be up to 15 characters for Windows VMs. It is also recommended that you follow a certain well-known naming convention for these machines, which will help in operations and maintenance. Let's call this VM VM2016. Next, you need to pick the disk type you want to allocate to this VM. Azure offers many disk types, and you can pick the right option based on your performance requirements and cost consideration. For now, we can choose the default disk type of Premium SSD. Next, you need to assign a username and password for the Windows operating system. Please assign a suitable set of credentials and remember them because, you will need them later while accessing the VM. And here we will confirm the password. And the next step is to pick the Azure subscription under which you want to deploy this VM. Whatever subscription you choose here, that subscription will be billed for this and cloud usage charges incurred for the VM. I have access to 3 subscriptions, so I can choose any of those subscriptions. Let's pick Visual Studio Enterprise 02. Next, you need to choose an Azure resource group. As discussed earlier, this resource group will allow us to manage all the related Azure resources as a single entity. Here you have the option of creating a new Azure resource group or pick an existing one. We will create a new one because this is the very first resource we are deploying for this application. So let's call it Cloud Native. We can use this resource group to deploy all the related resources for this application. And once we're done with them, we can delete them all by getting rid of the resource group. Next, We can choose a location for our virtual machine. Azure has data centers across the world. Here we can choose exactly in which geographical region we want this VM to be deployed. Choosing a location is very important when you're having a geographically distributed traffic from your customers. Suppose you're in charge of architecting an e-commerce application which has 90% of its customer base in Eastern USA. Well, then you should probably deploy the VM in US East. That way, most of your customers will get low latencies while connecting to your e-commerce site and thus enjoy a better user experience. Next, you can save some cost on the VM by supplying your own Windows license. For now, we will use the default value and let Azure provide us a license. Now we'll click OK. Next step is to choose the size for your VM. This basically controls the hardware capacity allocated to your VM and thus the cost of running the VM. The larger the VM size, the more powerful the VM hardware and the costlier it is to run. Please plan your VM sizes carefully to utilize your cloud computing budgets optimally. Since we're using this VM for educational and development purposes, we do not need a huge VM size, so we can go with VM size D2SV3, which has 8 GB of RAM, which will be more than enough in carrying out our workloads. Click on Select. Next step is to configure additional settings for our virtual machine. First is high availability. Since this is a development virtual machine, we don't need to configure high availability for it. Furthermore, rest of these settings like the virtual network, subnet, public IP, network security groups can be accepted as default. You don't really have to tweak them. One important setting that you do need to change is this public inbound ports. Make sure you select RDP, HTTPS, and HTTP ports here so that you can communicate with your VM. If you do not open these ports, by default, Azure firewalls will block any traffic to the VM and, well, you won't be able to access it. Accept the default values for the rest of the settings and click on OK. Now, Azure presents us with a summarized view of all the options we picked for this VM. Please review it carefully and most importantly, please pay attention to the hourly cost you will incur for running this VM. This cost is shown here in this summary. And once you're satisfied with all these settings, accept the terms and conditions and click on Create. Now Azure will get busy and it'll start the VM deployment. Azure confirms it via the notification. Currently, the status is submitting deployment. To get to a more detailed view, click on this status notification. This brings you to a dedicated dashboard view about this new VM. You will find all kinds of details about your VM here, and on this left-hand panel, you'll find the controls to manage your VM. In the notification bar, we can see that the deployment of our VM has succeeded, so let's go ahead and navigate to a resource. Here we are brought back to the VM dashboard, and we can see the status here, the location in which it is currently residing, and its size, as well as the public IP assigned. Let's go ahead and connect to this virtual machine. Typically, we connect to Windows virtual machines via a remote desktop or RDP connection. Click on this Connect button, which will download the RDP connection file. This RDP file will contain the necessary details for you to be able to connect to the remote VM hosting in Azure Cloud. Okay, the RDP connection file has been downloaded to our local machine. Let's open the RDP file. A new remote desktop connection dialog pops up. So click on Connect. And now we need to enter the credentials which we assigned to this VM while creating it. Click on OK to proceed with the connection. Here, RDP will ask you to confirm whether you want to connect to the remote machine. You can choose to check this checkbox to remember your decision. Anyway, we do want to connect to the VM, so let's click Yes. Let's wait for the RDP connection to be established. Okay, we have logged in successfully. The first time you connect to your VM, it may take slightly longer as Windows initializes some system settings. Let's allow the initialization process to finish. Now we are inside our virtual machine. As a first step, let's go ahead and disable the firewall for this VM. Now, this is done only for convenience sake for the development phase. For production environments, you should consider a more fine-grained security configuration for your VMs. Disabling the firewall will help while we install any third-party software on this VM. With the firewall disabled, we can just go through that process quickly. To disable the firewall, click on the Windows icon, then click on Server Manager. Microsoft Windows Server Manager is a tool to view and manage server roles and make configuration changes. Server Manager allows administrators to manage local and remote servers without requiring physical access to the servers or enabling remote desktop protocol connections. Wait for the Server Manager to initialize. Click on Local Server. This brings you to the dashboard page about your local Windows server. Here you can review a number of details about your server. For instance, the name of your Windows Server machine, the amount of RAM allocated to your VM, the processor it's using, and here you can see the Windows Firewall options. Currently, the status of the Windows Firewall is public on, which implies it is on the public network and it's currently switched on. Click on the status link. This brings you to the Windows Firewall Control Panel applet. Here on the left-hand panel, click on Windows Firewall status on/off. So turn off Windows Firewall for both public and private networks. Once again, this practice is only for convenience purposes for this educational exercise. Please do not turn off your firewall in production environments. Then click on OK. Let's close this control panel applet and the Server Manager. And now, let's get on with the installation of prerequisite software installation. You have been provided with the accompanying resources. One of the resources is called the All Files folder. You can copy this folder into your virtual machine, as we will be using the content of this folder throughout the course. You can open this folder. You can see the resources have been arranged in these subfolders corresponding to the sections of this course. Navigate into subfolder called Section 1, and inside this folder you'll find a text file. Inside this text file, you have the installation links for the necessary software to be installed here on this VM. These software packages are necessary for the upcoming demos in this course. So open this file. So first we install the Java JDK. Copy the second link for Java JDK download. Open a new browser window and navigate to the link. Here you're on the Java SDK download page. First, accept the license terms and click on this link for the Windows installer package. The actual file size is 390 MB, so it may take a few moments to download depending on your internet connection speed. Okay, now you can see that the installation file download is complete. Let's open the installer by clicking on the file. Click Run and install the JDK. The Java JDK installer starts. Click Next. Let the installer install the necessary components on this system. Click Next to proceed. Okay, great. The JDK has been installed successfully. So close the install window, head back to the JDK install location. By default, Java JDK is installed at programfiles/Java. So copy this path. We need to use this path and set a system environment variable. Right click on this PC, click on Properties. Here in the System Properties applet, click on Advanced System Settings. Here, click on Environment Variables. And here you take two actions. First, you need to update the path environment variable, and you also need to add a new system environment variable to point to the JDK installation location. So let's take care of those now. First, you need to edit the path system variable. Select the variable, click on Edit, and here append the location of JDK that you copied earlier, and click on OK. Next, you need to add a new system variable named Java_home. So click on New. A new system variable dialog pops up. Enter the name for this variable Java_home and paste the same JDK path here in the value text box. Click on OK. Click on OK again. This part of the configuration is done. Now let's verify if the JDK has been installed successfully. Open a command prompt window, and here we can execute the command java -version. As you can see, Java version 10.0.2 has been successfully installed. Next, you need to install Maven on your VM. Maven is a popular Java build framework, which we will be using to build our Java application. Head back to the text document and copy the link for Maven installation. Open the link in a new browser window. Here's the installer download page for Maven. Let's download the installer binary files. Download the binary zip archive. Wait for the file to be downloaded. Okay, the installer has been downloaded. Now we can open this file, copy it, navigate to the C drive and extract it here. Once extracted, navigate into this Maven folder, navigate to the bin folder and copy the path. Now we need to set up an environment variable path for Maven as well. So we navigate back to the system settings, click on advanced, click on environment variables. Once again, select the path variable and edit, click on new, paste the path for Apache Maven, click on OK. Additionally, we need to add a system variable as well. The name of this new variable is maven_home. So we paste the full bin path for the Maven installation here in the value field, click OK. Most applications will work fine with this Maven home variable, but some applications refer to an alternative variable called m2_home, so let's set that up as well. Click new, call this variable m2_home, paste the bin path for Maven installation in the value field and click OK. Click OK again. So let's open a command line window and verify the Maven installation. Execute the command maven ---- version. And from the outline, it is verified that we have Maven 3.5.4 installed on this machine. So with that, you should have successfully installed Maven and JDK in your Azure VM. Now the last prerequisite software that you must install is the Azure CLI or command line interface. The Azure CLI is Microsoft's cross-platform command line experience for managing Azure resources. To download and install the CLI, you can navigate to this link in your favorite browser. Azure CLI has a straightforward installation process. You don't need to set up any environment path for it. Once done with Azure CLI installation, your virtual machine on Azure is ready, and you can now proceed to the next step of building your cloud-native app. So in this section, we have discussed what cloud-native apps are, why we need them, and finally, we set up our environment for cloud-native apps on Azure. For that, we used an Azure VM and installed Java JDK, Apache Maven, and Azure CLI. In the next section, we will build a Spring Boot application which will provide CRUD functionality to manage your to-do items. See you there.